Hello, fellow explorers of the digital frontier. Welcome to PaperLedge, where we transform cutting-edge research into something you can actually, use. Today, we're diving into a paper that's not just pushing boundaries, it's practically teleporting us to the future of video generation. We're talking about InfinityStar, Unified Spacetime AutoRegressive Modeling for Visual Generation. Now, I know what you're thinking. Autoregressive spacetime, what now? But stick with me, because under all that jargon is something genuinely revolutionary. Imagine a single AI that can generate high-definition images in videos, understands text prompts, and can even predict what happens next in a video, all with blazing speed. That's InfinityStar. The core idea? A unified spacetime autoregressive framework? Let's break that down, Feynman style. Imagine the universe as a giant tapestry. Each thread represents a moment in time, woven together to create a seamless visual experience. InfinityStar is the loom, masterfully capturing how these threads connect, both spatially what you see in a single frame, and temporally how those frames evolve over time. But how does it actually do that? Time for a journey into our first memory palace. The pyramid of visual dreams. Picture a colossal pyramid, stretching towards the cosmos. Each layer represents a different scale of detail in the video. In the base layer, we have the roughest sketches of the image, the overall composition. As we move up, layer by layer, the details get sharper, the textures richer, until we reach the very tip, a single, perfect pixel. InfinityStar uses this pyramid to generate images and video, starting with the big picture and gradually filling in the fine details. It is like sculpting a statue. First you carve the basic form and then you use smaller tools to create the intricate patterns. Now, this pyramid isn't just for show, it's the key to InfinityStar's versatility. One moment it's generating a stunning landscape from a text prompt. The next, it's extrapolating a video, predicting what happens next with uncanny accuracy. It is like a Swiss Army knife of visual creation. But InfinityStar doesn't just look at each frame individually, it considers the flow of time, the relationship between frames. This is where the space-time part comes in. Think of each video as a winding river, carving its path through time. The AI doesn't just see snapshots of the river. It understands the currents, the eddies, the way the water flows from one point to the next. Okay, so we have this spacetime aware pyramid thingy, but how does InfinityStar actually learn? That's where the magic of autoregression comes in. This is like teaching a computer to write by showing it examples and having it predict the next word, then the next, and the next. Each prediction refines its understanding, allowing it to generate increasingly complex and coherent text. InfinityStar does the same, but with images and video, learning to predict the next visual token, the next brushstroke in its digital masterpiece. But here's the kicker, previous autoregressive models have been, well, let's just say they were about as efficient as a caffeinated sloth trying to solve a Rubik's Cube. InfinityStar? It's like they strapped a rocket to that sloth. The authors achieved this speed boost with a few clever tricks. First, they inherited knowledge from a continuous video tokenizer. Think of it like this. Imagine you're learning to play the guitar. Would you start from scratch, or would you learn from a musician who is already a pro? InfinityStar does the latter, learning from a continuous video tokenizer. This is a network that can convert each frame of a video into a series of small data tokens, in effect compressing the visual information. Second, they introduced something called stochastic quantizer depth. Don't let the name scare you. Imagine a painter deciding which brushstrokes are really important. Stochastic quantizer depth forces the AI to focus on the most crucial details, making the learning process more efficient. And finally, they implemented something called semantic scale repetition. Imagine a chef tasting a sauce over and over, each time refining the flavors, until it's absolutely perfect. Semantic scale repetition forces the AI to refine the most important features of the video over and over, improving the overall quality. It's like a painter adding layer upon layer of glaze to bring out the richness and depth of a masterpiece. Now, all this technical wizardry is impressive, but what does it mean? Well, the results speak for themselves. InfinityStar achieves state-of-the-art performance on video generation benchmarks, outperforming previous autoregressive models and even rivaling some diffusion-based models, all while being significantly faster. A 5-second, 720p video generated 10 times faster than the competition? That's not just incremental progress, that's a quantum leap. InfinityStar is the first autoregressive model capable of producing industrial-level 720p videos. The authors themselves have released all of the code and model to foster further research. So, what's the big picture? InfinityStar is more than just a cool new AI. It's a glimpse into a future where creating high-quality video content is easier, faster, and more accessible than ever before. Imagine filmmakers being able to quickly prototype scenes, storytellers bringing their visions to life without the need for massive studios, and educators creating engaging and immersive learning experiences. Of course, like any emerging technology, there are challenges and potential pitfalls. But the potential benefits are undeniable. So there you have it, InfinityStar, a unified spacetime autoregressive framework that's pushing the boundaries of video generation. It's a complex paper, but hopefully, we've managed to distill the key insights into something digestible. Now, I encourage you to dive into the paper itself, explore the code, and see what amazing things you can create. The future of video generation is here, and it's waiting for you to explore. Until next time, keep exploring, keep questioning, and keep pushing the boundaries of what's possible.